It is that time, my friends. We're live. Double checking, making sure people can see me on their end, making sure that it actually is streaming, and it is. Right on. What's up, everybody? Welcome. Welcome to another Deep Learning Daily community powered by Deci technical session. These are our typical Friday hacky hours. This is a special Friday hacky hour because typically we do this only in the Discord community. If you haven't already joined the Discord community, you can check it out by going to deeplearningdaily.community, and I'll take you right to the Discord community. But we're doing this one live on LinkedIn, streaming it through YouTube as well, because we have a very, very special guest with us today. So our guest today is actually a YouTuber who's got a popular channel called Neural Hacks. It's got about almost 2,000 subscribers at this point and growing quickly. So I suggest you look him up on YouTube and get in on that ground floor. So his channel focuses on content that's related to state-of-the-art technologies in natural language processing, especially large language models. And includes a lot of technical demonstrations on how you can create applications using large language models. He also showcases how to fine-tune state-of-the-art LLMs for custom use cases. He also explains and implements research papers and does a lot more. Some of his interesting works that he's done so far have been a real-time AI research agent, the AI girlfriend, a variety of different chatbots, as well as doing some work on the DPO and LoRa research papers. And he's also explained the DeciLM model, and that's what we're going to talk about today. So as you guys all know, with large language model usage, performance has been increasing continuously. They're doing really well on a variety of tasks, but for commercial use cases, it's really, really important that inference is fast. So when it comes to inference time, we can't have your users waiting around to get the answers, right? So that's what we're going to kind of touch on today in this presentation. We're going to learn how to fine-tune the DeciLM 6B language model for a custom use case. And then Vasant is also going to show us how to create an inference pipeline with that fine-tuned model. We won't be fine-tuning it we won't be watching it fine-tune on the screen, but Vasant is going to walk us through some code and kind of give us a high-level overview of the process. With that being said, I just want to take a moment to now welcome Vasant to the stage. Vasant, thank you so much for taking time out of your schedule to join us today.
Yeah, thank you so much, Harpreet. Thank you for the warm introduction. So, yeah, looking forward to a great session ahead.
Absolutely, man. Same here. And again, if you guys have not already followed Vasant on YouTube, Neural Hacks, do give him a follow. So with that being said, I'm going to go off stage and I'm going to pass it right over to Vasant. If you do have questions, whether you're watching the live stream, whether you're here in the chat, drop your questions in the comment section and I'll be sure to relay them to Vasant. So Vasant, take it away.
Yeah, so let me share my screen. So this session, it's going to be about how to fine-tune DeciLM 6B, specifically a variant of DeciLM 6B, which is instruct. Okay. So I'll say about the DeciLM 6B instruct at the later time. But the thing first which we need to notice, like Harpreet quoted, in this modern world, especially once the LLM came into the picture, everyone is moving towards giving some better results. Obviously, that is there. You need to provide better results. But the thing you should consider when you go for a commercializing use case is that you should also have a model which will be fast with its inference. And that is what DeciLM has achieved. And we are going to see how to fine tune that model for your own custom use case. So let me show my whiteboard so that in that I'll show you the agenda of today's session.
And while you pull that up, Vasant, I think something to note, is the difference between maybe a base LLM and an instruction tuned LLM. So DeciLM 6B, we got two flavors, right? One is the base LLM, one's the instruction tuned LLM. Can you just say a couple words about the difference between a base and an instruction tuned? Because they behave rather differently, don't they?
Yes, that's a great question. See, the point is instruction tuned LLMs have come into the picture from probably the later part of 2022. So around November, December was the time when instruction tuned LLMs were going so big once the arrival of Flantify has been in the field. The difference between a base model and an instruction tuned model is that a base model usually, which is in case of here a causal LM, is to generate and complete a incomplete sequence which is already there. Let's say I'm having a sequence stating that DeciLM is an organization, and then there is a possibility to continue it in any possible way, right? I'm not saying any condition stating that you should generate in such a way. But with instruct models, what they would have done is the model has a lot of knowledge that is there, but the sole purpose of instruction tuning is that your model will adhere to your instructions. It will try to follow your instructions. So that is why we'll be seeing how to fine tune DeciLM 6P instruct, because in most of our use case, we need our model to be strictly following our instructions, and that will be the difference.
Right on. Thank you so much. Appreciate you breaking that down, and we'll take it away to your whiteboard. So go for it.
Hope my whiteboard is visible. So
Yep. Yep.
this
Looks good.
is the agenda for, yeah, that's good. That's great. So this is the agenda for today's session, which is first I'll be giving you a brief walkthrough on the timeline of LLMs, because what I feel is when you're going to learn about a language model, it is very important that you know the roots of it. So we'll be seeing about a brief its history of timeline, or yeah, rather than history, I'll say like how these models were created. Okay, over time. And then next we'll see what is that makes DeciLM unique, because DeciLM is a model which will focus on a different aspect rather than the other models which are there in market, and I'll say about that. Followed by that, I'll give you a brief explanation about DeciLM's architecture, and finally we'll see a code walkthrough of how to fine tune DeciLM. So for timeline, let me show my slide. Sorry. So here we have there is this brief history of timeline here. Okay, here you can see at these all started with attention is all you need. Okay, so you all know transformers by now, I guess. That has been the root for all of these model which is there right now, and this has been the starting part for all of these. And then finally, if you see, all became very kind of trending and then hot topic once GPT came into the picture, which was on June 9, 2018. Then in October 2018, BERT came into the picture. So these two models were the ones which revolutionized NLP. And then we have BART and T5 being released in October 2019. So before going next, let me break you down with the difference between these three models and what makes these different from each other. GPT is a causal LM, and it is known as a decoder model. Okay, and BERT is an encoder model, and T5 is an encoder decoder model, and each has its own advantage. BERT, which is an encoder model, has the capability to represent and understand the context better, because the attention will be on both sides. With the case of GPT, it will be autoregressive in nature, which means it can see only the past and not the next one. Let's say you are having 10 tokens. If you are at the sixth token, it will be able to see and learn only from the first five tokens and not the seventh token, which is possible with BERT. Okay. but doesn't have the ability to generate content. Next, coming on to BART and T5. T5 has been a very great architecture released by Google themselves, who released Transformers paper also. So T5 is an architecture which is encoder decoder. So encoder will try to learn a context and decoder will try to generate accordingly. So things were going very fine, very smooth. There has been some constant increase in the kind of innovation, if you want to term it that way, in the field of NLP involving transformers. But all came into a storm when ChatGPT came into the picture, which was on November 2022. Okay, so November 2022, ChatGPT's first version came into the picture, which took the field by a storm because it had the ability to do anything a man can do. But immediately in December itself, there was this competition models being created, which is instruction tuned models. Because the thing with instruction tuned models is that it can be made to generate according to your, let's say, kind of wish, if you want to term it. Okay, so instruction is something like you are giving some guideline and the model wants to generate such, and that is done by Flantify. So Flantify I've explored it very much in depth, so I can say that it is very good. Next, what happened is in this year, in 2023, there have been lot of LLMs being released, out of which Llama was the standout one. But why I keep this timeline is after ChatGPT came, everyone focused on parameters because there was this GPT-3 model which was released in between, which was 175 billion parameters. And post that with ChatGPT, it was again a large model again. So people started working on large language models. So the thing which separates LMs and large language models is nothing but the name itself. It will be large in parameters. That's all. Okay. So it's just a fancy term, in my opinion. It doesn't make any difference if you are working with a language model or large language model. The architecture is going to remain same with some innovations, obviously. So some of these innovations are also even present in DeciLM, which are pretty good. So in current state, what is the problem? That is what we are going to see next. Okay. So let me take my pen. The problem in current scenario, which is performance. See, people are running towards performance, but like I said, it is also considered that inference is your performance again, because it's not just important that you generate a correct answer, let's say in 8 seconds or even 10 seconds for that matter. And if you can make a model which is generating in, let's say, 4 seconds or even 3 seconds, and you're compromising, let's say, around 2% of your accuracy, then it is a very good trade off, because in that time, let's say in 3 seconds, you will be able to cater 3 user in the time of 1 user, right? But with just a reduced being 2%, that is very less trade off. So yeah, that is a steal, and that is what makes DeciLM unique. So now we are jumping on to the second question, which is what is unique about DeciLM. So DeciLM is a model which gives high importance towards inference and latency while you are deploying it to the user. And it has shown some tremendous potential that DeciLM provides inference which is 5x faster than Llama 2. Okay, Llama 2 has been a state-of-the-art model, and DeciLM has been inferencing 5x faster than Llama 2, but it is approximately again 2 to 3% of accuracy trade-off, which is fine. All right. And there is another thing also with Llama 2, that Llama 2 is not again open sourcely available. Though it is open source, you can't use it for your commercial purposes. Okay. So now let's see what is the main reason behind DeciLM being that much faster. Okay. And there is another thing to note, that if you are using a special engine which is created by Deci themselves, you can achieve 15x faster inferences, which is claimed. by the research team themselves. Okay, so let me show you the architectural innovations which they have used. The first one is variable group query attention. So to know about that, you should first have an idea of attention. Again, in simple terms, you will be focusing on how much a word has importance towards other words. Okay, so there will be query key value, and for a given query, it will try to multiply itself with the query key, and then value will provide that, okay, this is this much importance. Okay, so that is the base idea of attention. But the problem was when you have n number of queries, the time taken was so high. So people started to make an innovation which was multi-query attention. Multi-query attention. What was that? Let's say you have a key and then there is a value. Okay, this is key and this is value. What will happen is, let's say you have 10 tokens. So what will happen is all 10 tokens will have query vectors and all will be mapped to the same key and then same value. Okay, so actually it should be value here and key here. So this is how multi-query works. This has reduced the inference so much, like, it gave very fast inference, but the accuracy compromise was too high. Okay, because one key wasn't enough for it to attend enough information. So next came group query attention. So what is that idea is, let's say you have a model which is um, having 10 tokens again as input. So what it will do is, you will have let's say three value vectors, and these three again will have three key vectors. Okay, these are value, these are key, and these three will focus on three vectors by themselves. Okay, so I hope that makes sense. So usually the best approach is given when you have n number of key vectors, n number of value vectors, and n number of query vectors. The value should be the same. But with group query, the trade-off is fine. Okay. So sorry. The trade-off has been fine with the case of group query attention. But again, here is where DeciLM gave an innovation in the architecture, which was they came up with a new style of attention, which is VGQA. Let me explain that. So let me clear my board. They came up with an architectural innovation known as VGQA. Like I said, there are possibilities that you'll have n number of groups, right? So let's say the thing is, with transformers you have a lot of layers. You'll have 32 layers in case of the latest model Mistral. So there are a lot of layers. Like in case of Flantify, you'll have 24 layers. And here, what they did was, again, they were thinking somewhat out of the box, and thought, okay, so why not have the same, rather than having the same number of groups. Let's say I'm having four here. I'll have two in one layer, four in one layer, and one in one layer, and I'll try to efficiently architecture it in such a way that I'll have some compromising in performance, but it won't be that much. But still, it will yield a very good performance rather than what it is achieved in multi-query. So you can say that this group query and there is multi-query, and this variable group query is kind of in between both of those. Okay, but the trade-off is very less. So that is what makes DeciLM very unique. So here you can see, right, group query, what happens is you'll have two queries here mapped to one key, and then it will have a value. With multi-query, it will be the same. But when variable group query, what they did was, in some layers, there will be four queries per group, and then there will be eight queries per group. So they just try to change the values in such a way that it won't affect the performance. Okay. So that was their main innovation here. And then there was this other thing which powered its architectural excellence, which is Autonac, the engine behind the creation of DeciLM, whatever models they have created till now, which is Deci Diffusion. Again, it is a model which will give fast inference, and it almost generates like stable diffusion. And they have also created Decicoder. Okay, and here they have provided some metrics. Now you'll understand why I said the compromise isn't that big. So here you can see there is Deci LM6P instruct, which is giving a performance on an average against benchmarks is 62.01, and Llama to 7 billion is 62.86, which means you're not even having 1% of compromise, but there is 2% when you compare with the base mode. Okay. So that's why I said it is 2% of difference, but still 2% is not that big of a difference. But when you see you are having 2% of accuracy being deferred, but you are having 5x faster. So that is a very good pro in case of using DeciLM, right? So here they have given this comparison that for a given second, with Llama 2, you can generate 136 tokens in PyTorch. And then with DeciLM, you can generate 652.5 tokens per second, which is 4.86, 8x faster. And the hardware in which they did was 8 in GPU, and the precision in which they worked was bfloat 16. Okay. But like I said, they have a special engine for inference, which is inferi LLM. And when you use that against Llama 2 7 billion PyTorch, 7 billion is again 136. But with inferi LLM being the backbone for the C6P, you will get 2020 tokens per second, which is 15x faster than what it is available with Llama 2 7 billion. And the cost cut, if you see, for a million tokens, it is $27 approximately with Llama to 7 billion, but it is only $1.3 with DeciLM. Okay, so that is what makes DeciLM very unique, because Deci doesn't just focus on performance, it focuses more on real world scenario. They try to avoid the constraint which is there with deployment of models. Okay, so yeah, here is the Hugging Face page of DeciLM. And what they did was, for instruction tuning, they took a subset of OpenARCA dataset and then they fine-tuned the base model, which is DeciLM 6P. And the license still remains the same as Llama 2 community license. And here for usage, it is given with some inference code, which we'll see later. And other than that, all of these we have seen till now. So I hope there is no questions. If there is any question, just let know in whatever platform you are in the comment section, and I hope I can answer it. So let me jump onto the inference code right now, because this walkthrough is something very important. And this code walkthrough, I'll go very slow so that you guys can follow and type if it is needed. Okay. So the first step is to install the dependencies. The dependencies here required is accelerate for efficient GPU computing, and then we have PEFT, parameter efficient fine tuning. So what is this library aimed at is, again, this is from Hugging Face themselves. This library is to create adapters. Okay. So LoRa, we'll be using LoRa for fine tuning, and LoRa adapters is available in PEFT. And then we have bits and bytes, which is used to quantize a model. And then we have transformers and TRL. Transformers is the core library, and the TRL provides the trainer in which we need to train on. So you can just run this. And then very important step is to log into the Hugging Face Hub. Okay. So let me show you what you need to do. First, go on to Hugging Face, create your account. So here is my account, Vasant. So you can also create your own account. Then what you need to do is go to settings, and then there will be something called access tokens here. What you need to do is just create new token. Let's say here it is DeciLM, right? So DeciLM session. it might be anything. It is for your reference, but make sure that it is in right axis, okay? Because you need to push this model to hub. So once you click generate a token, it will generate a token. So you can just click this button, it will copy the token, and when you run this, you need to paste in this. Okay, so once that is done, you're all set to go for fine tuning. Sorry, just give me a minute.
So far, so good. That love the presentation so far. If anybody has questions in the meantime, do let me know, whether you're here in the chat or watching on the live stream. I am monitoring the live stream, and I see there's about at least 20 people on LinkedIn watching. If you're watching this on LinkedIn, be sure to smash a like and repost, and take it away, Vasant.
Yeah, thank you, Harpreet. Since our installing dependencies section is completed now, we are ready for importing the dependencies so that we can be fine tuning it, right? Based on that. So the dependencies here are torch, and then we have load dataset and dataset being imported. Load dataset is a function and dataset is a class. Dataset is the common class for any Hugging Face dataset. And to load any dataset from Hugging Face Hub, you need load dataset function. And then we have LoRa config, AutoPef model for cos LLM, and get pef model being imported from peft. LoRa config is a configuration class which is used to set the configurations for creation of LoRa adapters. And then AutoPef model for cos LLM, it is to load a pef model. And then get pef model, again, AutoPef model for cos LLM is kind of a wrapper, and get pef model is what is behind AutoPef model for cos LLM, which will try to load your adapters attached to the base model. Okay, so here in this case, it is DeciLM 6P instruct. Now, coming on to the core imports, which is auto model for causal LLM, auto tokenizer, bits and bytes config, training arguments. And then we have SFT trainer being imported from TRL. Okay, so these are the imports. So now let's see how to fine tune it. First, coming on to the dataset, here I've considered Alpaca dataset because Alpaca is kind of a benchmark dataset. And if this model is able to work well with that, then it means it has a great potential. So I thought, okay, let's take this. Because if you see the questions, right, it would be very generalized. It won't have any context for it to reply with. For example, here they are asking about describe the structure of an atom, and it is giving some response here, which is pretty good. Here it is, you can see, right? Atom is the basic building block of all matter that is made up of three types of particles: proton, neutrons, and atoms. It goes on. Okay, it will have lot of domains in it, be it STEM or general knowledge. It will cover a lot of things. So I thought, yeah, let's do this. And the license is also CC by 4.0, which means you can also use it for your own use cases if it is needed. All right. So the first step is to load the data set, for which we need to provide the dataset ID, which we provided here. Next, we have the split which is needed. So here in this case, there is no other split. So it won't be very different, but there are a lot of scenarios where they would have uploaded train, test, and validation split separately. So in that case, you can provide the split here so that you'll have either train, validation, or test, or even you can load all of those at the same time as per your convenience. And here I'm saying, okay, I'm just considering the train split. Next, we have the data being converted to pandas. It is easy to work with a pandas data frame rather than a Hugging Face dataset. So I just converted it into a pandas data frame. That is what two pandas does. And then here we are just taking a 10,000 sample from this data, because obviously this is for some test purpose, right? We are not going to do it at an industry standard. But yeah, if you want, there are some changes which you can do, which I'll suggest. I'll say by before the session ends. Okay. Here, there is one thing to note, which is very important. When you're using SFT trainer, which is supervised fine-tuned trainer, which is usually used for instruction tuning. Okay, that is from TRL. It is very important that all of your input is falling under a single field, single text field. Here in this case, it is dataset text field parameter, for which I have provided the value called text. Okay. So for this, what I did is I'm doing an apply function so that I can combine these. Okay. Here you can see we have instruction, input, and output. There are only some scenarios where there is input. Other than that, it will be always empty. And here you can see, right? There is the instruction first, and then the input. Here also you can see evaluate this sentence for spelling and grammar mistakes. He finished. It won't make a lot of difference. I gone through the samples. It won't make a lot of difference if you place it prior or later, but I usually prefer to keep the instruction first and then the input next. Okay. So we are calling an apply function over this data frame on which we are creating a prompt template. Since we are using Alpaca, I thought why not we use the Alpaca prompt template as well. Alpaca prompt template is a template which uses hash 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 human is to, and then your human input be the instruction alone or instruction and input or anything which is provided by you will be there, and then there will be a new line character followed by which there will be hash 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 assistant stating that now it's your time to generate. This is a prompt template from Alpaca, which is from Stanford, and it is said that this increases your performance, and we have done that. So we have also provided the access equal to 1 so that it will be occurring column wise. Okay. Next we have, since we are done with the processing, because here you can see, right, we have all under a single column, which is data of text. Now we'll again convert this data frame into data set, because to work with Hugging Face ecosystem, it is very necessary that you have Hugging Face data set. So we'll be again converting this data frame into a data set by using from pandas function, which will take a data frame as its input, which we have provided here. Now coming on to the interesting part, where the first step is to load the tokenizer so that we can tokenize the input and provide to the model. So for which we are using the tokenizer of DeciLM 6p instruct, for which we need to provide the ID, model ID. Okay, so let me paste this here.
And real quick, while you're pulling that up, Vasant, there's a question that came in to the chat
Yeah.
here. And it was just from a couple of minutes ago, actually. And it was, what kind of data set should we prepare for fine tuning of a LLM? And how do we make it better from the data-centric approach? And then another question is, do you have the notebook that you can share?
Yep. For the second question, I'll answer it first. Obviously, it will be provided. Let me even share the GitHub link for it, because this is available in my GitHub. So let me share a GitHub link and you can provide it.
Awesome. Thank you. And be sure to go follow Vasant on GitHub as well as his YouTube channel, Neural Hacks. So definitely check him out there.
Yes.
Great. Thank you.
So yeah, provided the link for the notebook. And for the first question, it is an interesting question because these LLMs have great potential, and once Hugging Face came into the picture, your coding part is very easy. Okay, so you need not worry about how I'm going to create the model, how I'm going to uh, do the training pipeline. It is going to be very simple. Even I can say very clearly that you can use the same code for any of your use case if your data set is ready. All right. Now coming on to the core part, which is how to create the data set. See, there are a lot of ways to create a data set or make a data set better. Um, for LLM, it is very important that you have a kind of large data set, because it will have the potential to learn from a lot. And especially when you are using LoRa, it is very important that you'll have a big data set, because it is claimed that LoRa will give a big performance improvement with larger data set. Usually with these kind of small adapters, it is usually said that you will have good performance even with a smaller data set. So that is fine, something like that. Because even if you see, it makes sense, right? When we make smaller neural networks, it is enough with some smaller data set, but with some deep neural networks, we need larger data sets. But in case of LoRa, it is slightly different. LoRa works very well with large data sets. Okay, so try to create large data sets. That is first. And there is a lot of constraints with creating a data set. And if you are lucky enough to use models for that, then yeah, you have ChatGPT for annotation of data. You have a lot of state-of-the-art LLMs, which is very big and is very good in data generation. But there has been no model till now which has beaten ChatGPT to that. And to be more precise on that, whatever models has been fine-tuned on ChatGPT generated synthetic data has been having a significant improvement in the performance. So for example is DeciLM 6B Instruct, which is trained on OpenAI dataset, and it has a lot of ChatGPT annotations in it. So yeah, if you want, what you can do is either create a dataset and then ask ChatGPT to refine the data, or even you can say like generate data like this. So I hope that answers the question.
Yeah, and another question that comes up, you mentioned size of the data set. What would be an appropriate size for the data set, and does the number of parameters, uh, you know, inform how much data we should have?
Yeah. There is not a hard fast rule that for this much parameter you need to have this much data, but 10,000 is a good size for you to start with. If you are working in a low resource part, 10,000 is a good starting place for you, because with 10,000 you'll have wide variety being covered. But make sure that the 10,000 is not of same. Let's say you're having document extraction, it should not be of like I'll have a same template, I'll have different values in that. It is not going to work, right? You'll have different receipts or different invoices which you will face at the later part. So that 10,000 should be highly, like it should have high quality, high variety. That is very important.
Thank you.
So shall I move on?
Yeah, please. Sorry.
Yeah. Now let me, we have completed till this now. So the next step is again to load the data, load the tokenizer, because the model expects a tokenized input for which we are using DeciLM 6P instructs tokenizer. And it is very important for you to set the tokenizer pad token to be EOS token. Why is that? You see, when the model is generating some tokens, right? If the generation is about max length of 512 and you're having let's say around 128 as the answer, 120 tokens is the answer, it should not keep on generating, right? So what it will do is instead of generating some other tokens, it will generate an EOS token. And once the EOS token is generated, again the loop will be stopped. Okay, so it is very important for you to set the pad token to be EOS token. Next we have bits and bytes config. Now we are coming onto the model part. The bits and bytes config is a configuration file which will help you to load the model in a quantized manner. And it is very important for us to load the model in quantized manner, because this model is not possible to load without quantization in Hugging Face for fine tuning. Uh, Let me show you the size here, then you will understand. Here you can see, right, it is approximately 10 here and then 1.6 give or take. It is around 11, 12.6, not 11.6. So I'll connect this runtime and I'll show you the size of this. And guys, to make sure that to let you know for all of you that the size of the model doesn't just replicate with RAM size, VRAM, okay, or the GPU usage. Let's say if it is 10, it will be consuming at least around 12 or 12.5, something like that. And here, if you see in GPU RAM, it should be actually around 15 gigs, and system RAM is 12.7, and we have only 12.6 in our space, right? So what we'll do is we'll quantize this model and then we'll load it. Okay, so that is how we'll work with the model. for which we are setting that the model should be loaded in 4 bits. So we are setting the loaded 4 bit is equal to true, and the quantization type is NF4. There are some other methods as well, but we are setting it to be normal float precision 4. And the computation data type should be in float 16. Float 16 is now kind of a standard data type. And then we are also setting the use double quantization parameter to be true. Okay, so basically these are all some auxiliary parameters. The main parameter for you is load in 4 bit is equal to true. If you want to load in 8 bit, that is also possible. You can load it in 8 bit by providing load in 8 bit is equal to true. Other than that, everything is normal. Okay, so at the time we can just remove this parameter. Okay, now coming on to the model loading part, since our quantization config is ready, we'll provide the model's ID here and quantization config being the bits and bytes config, and provide the device map to be auto. So what is the purpose of device map is that with device map set to be auto, it will try to kind of efficiently allocate the layers to GPUs you have. So here in this case of collab, it won't make a difference because we have only one GPU and everything is going to be mapped to that GPU. Let's say you have Kaggle for now. Like recently, I saw that Kaggle are providing 29 gigs of VRAM. So that opens a lot of opportunities for developers who will work on open source, obviously. And in that case, they have provided two GPUs. Okay, to efficiently map these layers between that GPU. Defaultly, you can provide auto. Okay, so that is why device map is provided, and based on this device map and quantization config, the model will be loaded now. Next, it is model.gradient checkpointing enable. Actually, there is a recent error being occurred, so for which you need to have this function. Prepare model for k-bit underscore training. This is also an important function. Okay. So basically what happens is the first step is to set the use catch is equal to false. Why it is set is that we are not inferencing it, we are training it, right? So for that, you need to set the use catch parameter to be false, and to replicate the pre-trained performance and not affect it, you are setting pre-training TP is equal to 1. And then these two are very important right now. The first step is obviously uh, to prepare the model for k-bit training, which is k being 4 here. So you are just preparing the model for 4-bit training. It will just optimize the model for the training of in 4 bits. Okay, so if you don't use this function, there is a possibility that you might face code out of memory error. So for a safe bet, you can just first wrap the model around this function, and then you'll also set the model gradient checkpointing to be enabled so that it can store the gradient checkpoints and also load the gradient checkpoints. Now the model is kind of half ready for the training. Why am I saying half ready? Let me go to my notebook. Sorry, whiteboard. Here, the thing is with LoRa, right? You'll have the model here. Okay, this is model, and then what you'll do is you'll attach the LoRa adapters, and this will be your final model. Okay, so this is how your model should be. And here in this case, what happens is this will only be trainable. Sorry, and this will be frozen. Okay, so what happens basically is that people are sometimes having a misconception, which I've not faced till now, that if you load the base model, which is DeciLM 6p instruct without quantization also, you won't have that big of a difference in performance because this model is frozen. Okay, we are not training that model. We are training an equivalent parameter small model. Okay, so what we do is we'll have some target modules which you can provide, or by default it will take the attention modules. Okay, so it will try to have a separate layer being attached near to that. So we'll train that layers, which is the LoRa adapter layers, which will be less in size with the parameters. Okay, you'll be astonished by the results actually. This model will be having, let's say, around 0.3% of parameters being trainable compared to the original model. Let's say if the original model is having 6 billion, 0.3% of 6 billion, just imagine that. And this will give the performance which you will achieve while you are fine tuning the full model itself. That is what makes LoRa a very state of the art approach. Till now, it has been the state of the art approach, but I've heard a lot of things about Vera that has been a successor of LoRa. It seems probably that might do better things. All right, but for now, LoRa is the best you can afford in the market for efficient fine tuning because you see with collab it is very tough to fine tune large models, and LoRa has enabled us with that. In training arguments, obviously, this argument training arguments class is a wrapper class which will help us to provide all the values for training loop. So for this, we have provided the output directory. We have set the per device train batch size to be 1. You can also provide any number of batch size you want. And then we have gradient accumulation steps to be 1. Optimizer being paged Adam W 32-bit. This is something which is different than usual because we are using a quantized model. It is very important for you to use a paged optimizer rather than a normal optimizer because this optimizer was specially created for training models which are quantized. Okay, and then we are providing some learning rate, scheduler type, safe strategy. These are all fine, but like I said in the previous starting of the session, you if you are gonna fine tune for your use case, right, the first step for you is to increase the number of epochs and you should comment out this. Okay, you should comment out this, do both of this and train completely and you will get great performance. Because why I'm saying is here I fine tune only for 1000 steps, which is 1000 samples. Still I got a very good performance, but you can get a very better performance than what it is there now by fine tuning it for longer time. And we are saying that you should train in mixed precision by setting fp16 is equal to true. And we are also setting the push to hub is equal to true, which will push your LoRa adapters to the hub, but not the base model. But the base model is very important. So let me say you how to load that and then combine with the model also. That is also possible with LoRa adapters. So now you have the model which is ready for fine tuning because you have quantized it, you have attached LoRa adapters to it, so you are ready for fine tuning with the model. You have prepared the dataset, you have the LoRa config, you have the training arguments, you have the tokenizer, everything is ready. So all you need to provide is those parameters along with the max sequence length, which is 512 here. So at a maximum of 512 tokens, what it will do is it will try to truncate it. If it is not enough for 512, it will try to pad it. Okay, so yeah, padding and truncation will happen based on this 512. So with the trainer being created, obviously you'll call the train function to train it, and then we'll have a final function called push to hub, so that this thing will be pushed into the hub. And here you can see I fine-tuned it for 1000 steps, and for a quantized model at the end of 1000 steps. So here you can see, right, it was around 1.0, a loss of 1 with the quantized model. It is very good. Okay, so here I've saved it in drive. The adapters I've saved it in drive, but if you think it is not needed, then yeah, you need not have it. Okay, now what you need to do is call that autopef model for causal LM function, because like I said here, you can see, right, there is this adapters alone will be saved. It won't save the base model, but base model is very important for inference. Adapter alone doesn't work. But when you have the adapter separate and the base model separate, obviously one parallel to the other, still though there is a parallelization, there will be a negligible, not negligible, a significant difference in inference. So what we'll do is we'll load the base model and we'll try to attach the adapters, which will be the model which we fine tune now. And then we'll call another function called model.merge and unload. Okay. So what it will try to do is it will map the LoRa layers back to its original layers, and then it will push to the hub. Okay. So yeah, that is about saving the model. Next, obviously, we need to inference the model, right? For which obviously we need generation config. Okay, so generation config is a class again which will hold all the parameters necessary for generation control. So we are providing do sample equal to true, top case equal to 5, temperature to control the randomness, repetition penalty so that the tokens won't be repeated, and we are saying that the max new tokens would be 100. Okay, and here I've asked a question stating that I dropped my mobile phone in water, what to do? And here you can see the model gave a big response actually. If you have a cell phone, it is possible to salvage the device. If you act quickly, take the proper precautions. Here's what you should do. Turn off your cell phone immediately after dropping into water. This will prevent further damage from occurring. And then remove any accessories or cases that might be covering the charging port or the back of your phone. These could potentially block water from escaping when you plug your charger into. And then we have stopped it. Actually, we have stopped in 100 tokens, but we fine tuned it for 512 tokens. So if I had run it for 512 tokens, it would have been faster. But still, for this much large response, it took only around 13 seconds, which is pretty good. So yeah,
And
now
that's on a
we know, right?
T4. That's on a T4 as well, right? So that's
Yes,
really
that is a
impressive.
very basic GPU. Yeah.
Yeah. So if you had this running on an A100 or A10, it would be significantly more quicker. And typically, like in industry, when you're deploying a LLM, you're going to be using either an A10 or A100. But just for these purposes, you know, so that anybody can run this free Google Colab GPU, and still super quick. Sorry, go on for something.
Yep. Yeah. So now what you can do is, since you have this model, so what you can just push this model again. Here we call this model.merge and unload, right? You can once you push this model, you can just try to attach this with lots of frameworks. There is a framework known as LangChain, on which I've made a lot of videos. So I know that LangChain is a very powerful framework. They are trying to stabilize it for protection. So you can try to use this model for RAG, which is retrieval augmented generation, so that you can handle long sequences, and then use it for any use case you want. So yep, you can just have this inference code at the backend. Let's say you have a file called inference.py. Okay, so there will be this Streamlit application in which you will have the app.py at the front end, and you can load all of these and then expose this at an API. So you can do anything you want, but this remains as your crux. So yeah, thank
And
you all. I hope.
just look at the code real quick and scroll up to the part where you had the supervised fine tuner code. That supervised fine tuner, that right there, this trainer supervised fine tuning, this is RLHF happening right there, right? Right. It's not we can say that this is the supervised fine tuning trainer. When you hit trainer.train, this is what we're doing as a RLHF.
No, actually, there is a separate trainer for RLHF, that is reward trainer. This
Mhm.
is different. This is a step prior to RLHF. For you to create an RLHF model, first what you need to do is you need to create an SFT model. Followed by that, you need to create an RLHF model. But there is a very good alternative for RLHF, because RLHF is so tiring process to create such a data set. So there is this alternative called DPO, and that has been pretty good, because even recently from Hugging Face, they made a post on a model called Zephyr 7B, which was trained with uh, DPO, and that model has given some great performance. In that, they have concluded that DPO is better than RLHF.
Awesome. Thank you. Thank you for that. Thank you for that. Um, Does not look like there's any other questions coming in. Is that all you had for us today, Vasant?
Sorry.
I said, was that that's all you had for us today, right? So that's thank you so much
Yes,
for
yes, yes.
thank you for joining us and walking us through this notebook. You guys make sure to follow Vasant on YouTube, Neural Hacks. As you mentioned, he's got a pretty in-depth series of videos on LangChain. If you're part of the Deep Learning Daily community newsletter, I'll be sharing a link to that as well. If you're not already a part of Deep Learning Daily community, well, you can join us at deeplearningdaily.community. That'll take you right into our Discord server. Any other questions here at all? If you got questions, do let us know. Okay, does not look like there are questions. So thank you all so much for being here. Appreciate you taking the time to join us. And Vasant, thank you so much for taking time to prepare this presentation. Just curious, what are you also making slides available at all, or is that not possible?
Sorry.
Will you also be making slides available as well?
Yes, yes, yes.
Okay, he'll send it to me, and then I'll share it with you guys on the newsletter, which will go out later today. So again, thank you so much, Vasant, and appreciate you guys all joining us here. Everybody that was in the room, everybody that was watching live on LinkedIn and YouTube as well. Thanks for joining in. Cheers, everybody, and have a great weekend. Bye.